the numbers are letters. Here's a quick review on the numbers. We only have 3 digits, 1, 2, and 3. The real symbol of 3 is actually the symbol of pi, because people with strings figured this out a long time ago. And then what happened was writing came along, they became lazy. And they would first write the pi symbol like this, and slowly over time it grew. You see they first wrote the pi symbol, I don't know if you can see me right here, but they started like this. They went to the center, and then they came back around again, and then they would do their ticks. But then that slowly grew, and then we developed into the 3. Now, the line in the top, okay, so all the digits is only 3 numbers, 1, 2, and 3. We have 1, which is the 4, the center line of the 4, the top of the top, the bottom of the bottom. 7 is the same, the top, the bottom, they're all the same bottoms, all the same lines. 2, 5, and 8 are the same number. 2, backwards 5 on top of itself. The 3, which is the pi number, and then a different pi, with the top and then the bottom. Now this is just an adaptation of the 9-digit base. What we really have is a 27-digit base, and from this number, what I'm saying is the actual English letters are these digits. So let's just go through a couple of them, and we'll see if we can make sense of what I'm talking about. So we have P R B. 1, 2, 3. So what we have there is the 1, 2, and 3. I think you can see it. If we start with the L, F, E. 1, 2, 3. We have the V. We repeat the V, but add a line, and then we move the line through the V for the A. 1, 2, 3. Now there are several versions of these, and there's several different ways of laying this out. The best way is to make a list of the letters, and start crossing them off. A, B, C. So C is you could go one of my favorites is circle G Q. I must have been writing these down somewhere else. Okay, here we go. These are just going to be out of order, and there's a lot of different possible combinations that these could be. So I've already used L, so we're going to go with U, N, M. And then we need to go C, D, O. And then we can go, we'll use O again. So we can put the best way to do this, there's a lot of different combinations of things that can be 1, 2, and 3 in the English language. But let me start again. We'll just do one set. Now this is just one set. There's several different possibilities even within this one set. But we're just going to do this one set. V, K, A, which I've already gone through. T, J, I, which I've not gone through, P, R, B, L, N, M, U, D, O, C, F, E. These are just, there's a lot of different ones. So at the very end, we get an S, a G, which is a variation of an S, and a Q. And this at the end is very interesting because we get two letters at the end and the missing one. In this scenario, we get a W and an I. Now, the Plutonic shape symbols. This is the shape for the tetrahedron, the Y. Now, can anybody guess that this is actually the shape of the square? The X is actually the shape of the square because that's actually two tetrahedrons put together. And the Z is the actual shape. See if I can do this. Is the actual shape of the tetrahedron. I mean the octahedron. So the Z is actually, if I can do this right, the Z is actually I don't know if I did that so everybody can see it, but that's an 8-sided object, and that's what the Z stands for. So we have the Z backwards because in our alphabet, because all ancient languages start from left to right, right to left instead of right to left, left to right. So the actual numbers that we use are simply the these 27 digits, and I'm going to call them tensors. These 27 tensors are the actual letters of our alphabet. So the numbers are a 9-digit base group, but these are a 27 base group, and I believe that there is 108. So I believe that a tetrahedron has 4 sides, and the tetrahedron has 27 tensors that dictate its movement and all of its physics. So all of the physics would be held in 27 tensors, which makes 108 tensors. And if you actually figure out what a tensor is, you'll understand really quickly that each of these digits could actually represent a formula, a equation. And so there's 108 equations actually in the physics of the temperature, all of the physics of what this smallest unit of particle could exist in. And that's actually what we're looking at with these numbers. So it gets even more complex. I hope you follow through with the next video.